In this video, we're going to do some extra examples where we rationalize the denominator in a few different ways actually. So they get harder as we go. So in the first one, I want to start by just rewriting the bottom as a fraction. Okay, so it's 2x plus 1 on the top, and the fraction exponent on the bottom, so it's x to the 2/5. So remember, the root, the thing on the outside, is the bottom, and the exponent is the top here. So what we want to do is we want to manipulate this expression so that on the denominator we don't have any fractional exponents. So we only want integer exponents. That's what it means to rationalize. So no more roots down there. So in this case, what we want to do is multiply by a fancy 1. Okay, now our fancy 1 should be x to some power, because I want to multiply these together so that these powers sort of make an integer, essentially. So when we multiply with the same base, so the x's, what we're going to do is add the exponents. Okay, so that means that we want 2/5 plus something to equal an integer. Okay, now the easiest integer is the integer 1. It doesn't have to be the integer 1 that you pick, but that's going to be the easiest one. So if you subtract 2/5 on both sides, that means that our question mark exponent should be 3/5. Okay, so I'm going to multiply by x to the 3/5 over x to the 3/5. So when you multiply by 1, you don't change the expression. And now my denominator is going to be x to the 1. Okay, so no more roots. On the top, I'm going to have to expand this through. So it's going to be 2x to the, now this is exponent 1, so it's 1 plus 3/5. So that's going to be actually 8/5. And then I have plus my x to the 3/5. So now I have it so that there's no root in the denominator. Okay, so now for part B, and in fact part C, we want to actually remember the difference of squares formula. So if I have a squared minus b squared, it factors as a plus b times a minus b. Now, why this is useful is if we just have one of these in the denominator, and either a or b both have a square root, if I multiply by the other one, which we call the conjugate, I'm going to get a squared minus b squared. So if a has a square root or b has a square root, and I square it, the square roots are going to go away. So this is a nice way to eliminate square roots. So right now, this part is going to be my a, and the 2 is going to be my b. So what I want to multiply by is the same two things, so square root of x minus 1 and 2, but with the opposite sign in between. So instead of having a plus, I now have a minus. Okay, so that's my fancy 1. And then when we expand it all out, so on the top, I'm going to have 3 root of x minus 1 minus 6. And on the bottom, I'm going to expand it all out so you can see why this works. But we know that we're going to get a squared minus b squared. Okay, so we should get at the end the square root of x minus 1 all squared minus 2 squared. But let's use our FOIL. So we're going to have square root of x minus 1 times itself, so that's squared, minus 2 square root of x minus 1, plus 2 square root of x minus 1, minus 2, or so plus negative 2 times 2. And now we see that these middle terms are the same but opposite signs. So they actually equal 0 and disappear. So we have 3 root of x minus 1 minus 6 on the top. And now you see that we have our a squared minus our b squared. Okay, that always happens. That's why we do this. And I should just make a note here. We call this the conjugate of the other one. So square root of x minus 1 all squared is just x minus 1. And then we're going to subtract 2 squared, which is 4. So if I simplify that, the bottom is just going to become x minus 5. Okay, and that's how we would leave our answer. So notice that there's no more square root in the denominator. There will end up being a square root in the numerator. That's okay because we are rationalizing the denominator. Okay, one more. This one again is a little bit trickier just because there's so many more square roots. I'm actually going to start by simplifying the top. So maybe let's do it up here. Root of, when you have things that are multiplied in a square root, you can actually break them up. So this is root of 4 times root of x. So it's actually 2 root of x instead. Okay, so this is actually 2 root x plus 1 over 5 root x minus root 3. So we want to multiply by the conjugate. So that's going to be 5 root x plus root 3. Whatever we do to the bottom, we have to also do to the top. Okay, so now I'm not going to multiply this one out. Okay, we know that when we multiply the bottom, we're going to get 5 root x all squared minus root 3 all squared. That's our a squared minus our b squared. Okay, now when we expand the top, so using FOIL, I'm going to have 2 root x times 5 root x. And then I'm going to have plus 2 root 3 root x plus 5 root x plus root 3. Okay, now we can simplify this a little bit. So on the bottom, I'm going to have 25x minus 3. Now 2 root x times 5 root x. The root x's are going to become an x. And the 2 times the 5 is going to be a 10. And then for this part, just to make it a little bit nicer, like we did with the root 4x, we can put these together. So this is actually the root of 3 times x all inside the square root. So that's going to be plus 2 root of 3x plus 5 root x plus root 3. Okay, so lots of square roots going on, but basically the same principle. So notice that we don't have any square roots on the denominator, and that's what we were going for here. So we wanted to rationalize the denominator, and we've done that.